Okay, this is lesson 2.6, our final lesson, which is applications of rational equations. So where are we going to find them in real life? How do we deal with them? Well, this is what's going on. So we are going to find non-permissibles in rationals. We've already known how to do that. We're going to determine the solution algebraically, and we're going to solve problems. The biggest one we're doing now is solving problems. How are we going to make it make sense? Well, we come back to some basic equations that we dealt with way back in the day in grade 9. So these ones are called rate of work. Rate of work will always be set up as a ratio. Now, the ratio is including how often people do things. So for example, we've got Sheena, Jeff, they're two friends, they're sharing a paper route. Sheena delivers her papers in 40 minutes, Jeff can do the same thing in 50 minutes. She was a bit quicker. How long if they do it together? Well, basically we're going to set up our information in a chart. So you're going to see the information here. They've got Sheena, Jeff, and then together how much they can do. So she delivers her papers 40 minutes, here 50 minutes. What is the fraction of work? Well, she's done her route in 40, done his route in 50. So time over amount, time over amount. Now, what is the 1 equal for together? Yes?
That's one job, not one thing.
Exactly. It's the one whole job done. So for example, if we were filling a pool with 2 different hoses, okay, filling the pool is 1.0, okay, that is a full pool. So the right-hand side of your equation is always going to equal 1. So the way we generically write this is we're going to have time together over time alone plus time together. I'll have to back it up over here. Plus time together over time alone. So this basic equation right here, all equaling 1. So we would set that into 1 over 1 as a fraction, okay? Because we're dealing with fractions here. So time together over time alone plus time together over time alone equals 1 full job completed, okay? Now, when we're talking about this, we're going to set these guys into our equation. When we set up our table, this is always our equation. We get it from our final column. So, t time together, we don't know how long it takes them together, so that's just x, plus x time together, we don't know how long, and equaling 1. So to solve this question, I'll just let you write that down. So we can see how we've created the equation. We've got time together over time alone, time together over time alone. So each fraction is a person. So we've got Sheena doing the job, and then we've got Jeff doing the job. And then 1.0 on the right-hand side, that's the full job being completed. Now, if we did a lowest common denominator, it would be 200. We would have to multiply them together, or get a multiple of 40 and 50. Do you remember on our calculators how to find our lowest common denominator? LCD? Okay, let's just refresh our brains so we know what to do. We're going to grab our calculator, just hang on here. And we're going to find out between 40 and 50. So we're going to hit our math button, and then we're going to hit over to number, and then we're going to scroll down. And it's number 8. Okay, number 8. When we wanted our greatest common factor, we used number 9 for factoring. We use number 8 for lowest common denominators. So, number 8, we're going to say 40, 50. And it's going to tell us, let's see, it's going to tell us 200. Okay? So we find our lowest common denominator. We've got 200. So now what we do is we're going to multiply. Well, they're showing us that they're multiplying by 200. Okay? So they're multiplying this guy by 200, this guy by 200. What we would do is we're going to multiply by what's missing. Well, this guy is missing what? He's missing a 5. What's this guy missing? He's missing a 4. Okay, how come? How do I know that? Well, if I take 200 divided by 50, I get 4. If I take 200 divided by 40, I get 5. That's how I know what I'm multiplying by. All equaling 200 times 1. Now, why is it like that? Because remember, this is 1 over 1. So whatever I multiply to my bottom, I have to do to my top. Okay? So over here, I'm multiplying by 200 over 200. Okay? So now we get rid of our denominators because we convert it. No more denominators. We're left with our numerators. 5t plus 4t equaling 200. We're going to get 9t when we add like terms. So we have to add our terms. You don't have to use t for time. If you like using x or y, that's fine. And then we add our like terms and get 9t total, 9x if you like, equals 200. Why did they choose t instead of x? That's right, it's time. And remember, problem solving always uses variables according to the situation. So that's why we have t for time. So the time they would do it together is 22.2 minutes. Okay? So 22.2 minutes. Now this is going to give us a run on decimal. That's a rounded answer. Our lowest term answer would actually be 200 over 9. It doesn't math frac lower. Okay? But when we're taking a look at this, 200 over 9, we do need the actual digit value, 22.2. Okay? All right. Are there any non-permissible values in this case? No. Why are there no non-permissibles? That's right. There's no variable in the denominator. So if there's no variable in the denominator, there's no non-permissibles. So we would say no NPVs. Okay? And the reason why, we already discussed, is because there's no variables in the denominator.
Are we allowed to make changes to the different from primary to lowercase to uppercase?
Sure. Yeah, it looks like a plus sign. Exactly. That's why many will change it back to X. Yep, that's fine. Absolutely. So one of our problem-solving questions for rate of work is a practice question. So, and again, this is a rate of work question. This is Stella takes 4 hours to paint a room, and Jose takes 3 hours to paint the same room. How long does it take them to paint it together? So, looking at our question, we are going to set it up as time together over individual, time together over individual. So, we need to have Stella and we have Jose. So Stella, we don't know how long it takes them to paint it together, but we know Stella takes 4 hours and Jose takes 3 hours. And they're going to paint one complete room. Now we're going to find the common denominator. Common denominator is going to be 12. So we're going to have something out of 12 plus something out of 12 equals 12 out of 12. Now the 12 out of 12 is 1. Any digit over itself is 1. So now I'm going to multiply the top to create my 12. So on the bottom here, I would multiply by 3. So I'm going to multiply my top by 3. It's going to become 3x. The next one I'm going to multiply by 4. So I'm going to multiply my x by 4 to get 4x. I take a look and there's no variables in the bottom, so there's no non-permissibles. Okay? But now that I've converted my top, my denominators disappear. There's no more denominators. Now I add my like terms on the left. I'm going to get 7x's equals 12. We divide out what's sitting beside our variable to both sides. And this tells us how long it takes them to paste it together. So 12 divided by 7, 1.71 times. So it takes them just over an hour, almost an hour and 3/4 to paint the room together. Okay? That's what this tells us. 1.71 hours. Okay? Any questions on the rate of work so far? So these sets of questions typically don't create a quadratic. This one, we're going to have a variable in the bottom. Instead of using the variable t, we're going to use the variable x. Okay, we're just going to substitute. They've given us the equation. So it says, Lyle can fill his bathtub in 8 minutes with cold water. When both the hot and cold water taps are on, he can fill it in 6 minutes. How long would it take him to fill it with only the hot water? So we've got the cold water tap, the hot water tap, and then together. So they're doing it together in 6, okay, minutes. Cold water can do it in 8. We don't know how long the hot water can do it. So now when I look at that equation, what would be my common denominator? They're both different. Well, there's 3 of them actually, because if you put a 1 underneath your 1 there to create a fraction. So you've got an 8, an x, and a 1. You slam them together, and it'll be 8x. You just put them side by side. So our common denominator is 8x. And to create a 1, the 1 over 1, you multiply 8x over 8x. All right. Over here, we've got a 6. Over here, we've got a 6. What do we need to multiply to the top 6 on the left to create 8x? An x. Beautiful. What do we need on the right-hand side? An 8. Good. We have to multiply it by 8. Now that we have done so, we need to check and see if we have a non-permissible. Do we have a non-permissible? And what would it be? 0. Now let's make sense of that. That means we're trying to find out how long the hot water tap could fill it by itself. Well, that means we have to turn it on. If we're going to turn the hot water tap on, that means time is running. Okay, so we can never have a time 0 for that because they're actually timing how long it's going to take the hot water. So it makes sense that we can have a non-permissible x cannot equal 0. Okay, so x can't equal 0 here. Now we can get rid of our denominators because we've combined them and created the same. Now we literally solve the equation. So we're going to have 6x plus 48 equals 8x. Now, we can do a couple different things. We like to take x to the left. We could trade places with the 48 and the x and they both become negative. Or we could simplify things and just move one of them. Which one could we move by itself? Just the 6x, right? So I could move this 6x, come over with the 8, and that's what I'm going to do. Try and reduce the amount of steps possible for yourself. That reduces the chance of making an error. So we're going to make a 0 pair. So to remove it, you have to do the opposite. Right now he's a positive. You've got to subtract him. So we're going to subtract 6x over here.
Can you still, like, do the flip thing where you...
Yeah, you betcha. You can flip your equation around. Now we're going to add those, and we're going to get a 2x. So the question is asked, because there's an equal sign, can I just switch places with the 2x and the 48? Yes, you can, if everything on both sides switches places. So if I just write the 2x and the 48 over here, yes, I can do that because everything moved. Okay? All right, last step, divide by what's in front of your variable. Now we're going to get x is equal to 24. So the hot water tap is going to take 24 minutes to fill it all by itself. Why do you think the hot water tank takes so long to fill it, the hot water tap?
You can't give away if the tank has to
Exactly. That's exactly what it is. If you ever notice you turn your hot water tap on, it takes a while for it to really heat up, doesn't it? Okay? That's what's going on here. It takes a while for it to heat up first, and then it can fill the tub. It also runs slower. It runs slower than the cold water tap because of the heating process. Okay, let's take a look at our next example. Okay, now we're going to start our upstream, downstream motion problems. When we've got upstream, downstream questions, there's two things you need to recognize. They're either going to be talking about how fast the current is, or they're going to be talking about having you find the current being still water. Okay? So, for example, we always take upstream plus downstream equals total time. Now, how do we actually set this up? Well, it's a speed, distance, and time question is what it actually is. So what we do is this. We're going to set it up this way. So we'll come back to this equation in a moment. We're going to set up a chart. Whoops. We're going to set up a chart. Yep. Charts organize your information. So we're going to have upstream, downstream. We're going to have distance, speed, time. This is a normal distance, speed, time question. Now, you guys have done these in physics and in probably some biology. You tend to use what's called a triangle equation. So my triangle equation is this. Distance, speed, and time. So if I want to find distance, I'm going to take speed multiplied by time. If I want to find speed, I'm going to cover it up, and I will find distance over time. If I want to find time, I cover it up, and I get distance over speed. Okay? So this is how you can organize your information. Now we're going to find out what our distance, speed, and time equations are. So time is equal to distance over speed. Okay? So these guys are going to be d over s. That's what time is going to be. Okay? Well, what is our distance going upstream? Well, it tells him he rows his boat 24 kilometers downstream and then back to where he started. So does that mean he's going 24 both ways or 24 in total? 24 both ways. It says he goes 24 downstream, 24 kilometers, and then it says he turns around and goes back. Well, if he turns around and goes back, he's going to go the same distance. So he's going to go 24 kilometers. Then it says when the average speed of the current is 2 kilometers. Okay, that's the average speed. He can complete it in 9 hours. Well, we need to figure out a speed equation. Well, what are we going to have for speed? Well, speed is going to be the current plus or minus 2 because it says the average speed of the current. Well, do we know how fast we're actually going downstream? No. It's going to be however fast we're going in our boat plus the current. Same as upstream. It's going to be however fast we're going minus the current. So let's take a look at that. If we're going upstream, we're going to be going faster upstream, correct? So if we're going to go faster upstream, we're going to have, backwards. I'm going down. You're going downstream, so think of it as going down a river, okay? And literally think of it as a hill that you're going to go down. So if you're going downstream, think of it as a hill, okay? We're going down, and if we're going downstream, we pick up speed, okay? So we're going to have speed minus the current. So we're going to have we're going to add the current. We're going to add the current speed. Because however fast we're going to pick up speed with that current going downstream. If we're going to go upstream, we're fighting against the current, aren't we? So we have to subtract the current. I mixed up and down again? Good grief. Up. Okay. Now that we've got them proper, we're going to go 24 divided by x minus 2. 24 divided by x plus 2. Okay? So yes, downstream, you're going faster, so you're adding the current to your speed. That's why you're adding the current. Here you're fighting against the current, so you're going to be going slower, so you're subtracting speed. Okay? So here we subtract speed because we're going slower. Okay? This one is faster. And if you have to write slower and faster down, do it, because I've got it on my book and it helps if you're looking at the right one. So, now we got this section. This is our equation. We've got our upstream plus our downstream, and then we know what the total time it takes them. So, we go back up and it says the total time is 9 hours. So now we create our equation this way. We're going to take both our upstream and downstream, and we're going to have 24 over x minus 2 plus 24 over x plus 2 equals 9 hours. And we're putting 9 over 1 and we're creating a fraction. Okay? So the rate of work problems went quite well. Okay? These ones take a bit of thinking. We've got to think through the questions. Typically, they will give you hints. Okay? Now, the biggest thing you've got to remember is downstream, you're going way faster. Okay, so you're adding speed. So that's why it's always adding below the downstream. So we've got upstream plus downstream equals total time. Okay, that's what we've got going on. Now we have a common denominator. Our common denominator is both sets of brackets. So that means that the 9 is going to multiply by both sets of brackets, x plus 2, x minus 2, x plus 2, x minus 2. I need both of them for my common denominator. So which one is the guy on the left for upstream missing? X plus 2. So that's what we're going to multiply to the 24, x plus 2. The other guy is missing the x minus 2. Remember, you've got to do it to the top and to the bottom. Now we do our non-permissibles. Okay, before we can erase our bottom, we must do our non-permissibles. So our non-permissible values, x cannot be what? Plus and minus 2. Good. All right. Now we need to get rid of our bottom. It is 100% gone. Now we're back to just the top. We need to multiply into the brackets. So I'm just going to write it a little bit neater for us. So we're going to have silly things. Okay. 24 times x plus 2 plus 24 times x minus 2 equals 9 times x squared minus 4. Now, how did I get my x squared minus 4? Who knows how I got x squared minus 4 right there? Yes?
Like the x plus 2 and the x plus 2.
That's right. I FOILed the x plus 2 and x minus 2. So, I took this right here, and I FOILed it, and it became this. Okay? So you FOIL it or area box, whichever you find the easiest. Okay? Now we're back to just solving in the brackets. So we multiply into our brackets to get 24x plus 48, another 24x minus 48 equals 9x squared minus 36. And what we try to do at this point is we have to add like terms on both sides. So we're going to notice that a positive 48 and a negative 48, they're going to cancel and disappear. So all I'm going to have is a bunch of x's on the left. So I'm going to add all these x's. I've got 24 of them right there, and another 24 of them here. So I'm going to add those guys up, and I'm going to get 48x equals 9x squared minus 36. Now, just like we did previously in solving equations, whenever we've got an x squared, we need to take it to the side where he's positive. So all the information has to go to that side, and then it equals 0. So that means 9x squared is positive where he's sitting. So I'm just going to take this 48, and he's got to go hang out with those guys. Now he's going to split the two of them. He's got an x, and whenever we use these questions, we have to have it in general form. Ax squared plus bx plus c equals 0. So that means that 48 with the x has to sit in between those two numbers. The 36 is taking his negative sign though. Okay? Alright, how do you move a positive 48 across the equal sign? You subtract it. So it's going to become negative 48x. And he's going to come over here as a negative 48x. So now we're going to rewrite it. And we're going to get 9x squared minus 48x minus 36 equals 0. Here we go. Okay, so now at this point, we're back to regular factoring. We're going to take a GCF of 3 out. It must stay on the outside of the bracket, a GCF always. And we're going to get 3x squared minus 16x minus 12 equals 0. At this point, we are now going to do a diamond on 3 times negative 12 is a negative 36. And on the bottom is a negative 16. Okay? Because this is my A, my B, and my C. On the top of your diamond is A times C. The bottom is your B. At this point, we take a look and see what's in front of x squared. X squared has a digit in front, so we must factor 3. The factors of 3 are 3 and 1. So we're going to have a 3x and a 1x to start our brackets. That also means whatever I put on the sides of my diamond, I'm going to divide them by those numbers, 3 and 1. So one of them is going to divide by a 3, and one of them will divide by a 1, depending on which numbers are going to give you no decimal answer when I divide. So when I'm doing this, we factor 36. So I'm going to take a negative 36, and I'm going to have 1 times negative 36, 2 times negative 18, 3 times negative 12, and we've already found our pair. Okay, so you keep factoring the last digit, the top one, AC, keep factoring it until you find the pair of numbers that adds to the middle number. Now, how do we know that the big numbers have to be negative? The bottom number here, the B value, whatever sign he is, he's negative, he'll tell the big number to be his sign. If he was positive, the big number would be positive, and the little numbers would be negative. So, this guy bosses them around, the B value. So, the signs of the big number are going to match the B value. So now I know I'm going to use a 2 and negative 18. Now negative 18 is going to be the one that divides by 3, and the 2 will divide by the 1. Now since we've divided them, their answers have to go in the opposite bracket. They cannot go into the bracket who they divided by. So that means the 2 divided by the 1, his answer goes in the guy without the 1. So his answer goes over here. And then the other guy is going to go to the bracket without the 3. Okay? So now we've got our guy factored. But those are just the factors. That's not solving for x. I need to solve for x, which means pull it out of brackets. So that means this has to come out of brackets, and this has to come out of brackets. This is problem solving, remember. Problem solving, we only care about a positive answer. This one's going to come out as a negative 2/3. Is that going to be a possible answer for us? No, we don't want negative answers in problem solving. So then I look at my other number, he's coming out as a positive 6. This is our only solution. Now we look and see if it's one of our non-permissible values. Our non-permissibles here were plus and minus 2. Our answer is not 2, so yes, positive 6 is our solution. Now we're going to go up and see how fast the current was going. How fast was everybody going? So if we go way up to our question, and we go to our question right here, this is going to tell us how fast each of them were going. So right here, downstream, if I put this, or upstream, pardon me, if I put a 6 where x is, 6 subtract 2 is 4. So upstream, they're only going 4 kilometers an hour because they have to fight that current. Downstream, we're going to take 6 and add the 2. They're going to go 8 kilometers downstream. Okay, so that's the information we're finding. Okay?
What is it?
Okay, our second motion problem. We have a boat that's traveling at average speed of 15 kilometers in still water. Okay? So they're giving us the speed of our boat. Last time they didn't. The boat travels 12 kilometers downstream in the same amount of time as it travels 8 kilometers upstream. Last time we had a total time of 9 hours. Here they're saying they're doing it in equal time. So that means I'm going to be setting up my equation as upstream equals downstream is what we're going to do. The distances are different. So we need to set up our chart. Okay, we've got our upstream and our downstream. We've got distance, speed, time. So upstream, he travels 8 kilometers. His distance is in kilometers. Downstream, he's going 12 kilometers. So the distances are not equal this time. Speed, it says he's going 15 kilometers in still water. So we need to know the current. We don't know how fast the current's pushing. So we know this guy's going to go. Upstream is going to be the current minus, 15 kilometers minus the current, because you're going to fight the current going upstream. Downstream, you've got to add the current. Okay? Downstream, you've got the boat plus the current. You're going faster. Okay, this guy is faster downstream. So if it's faster, you're always going to be adding. Come on now, what's going on? Come on, Lord. It's not cooperating. Okay, that's just fine. Now we're going to do time. Time is always distance over speed. So we just set up our ratio. This is going to be 8 over 15 subtract x. This is going to be 12 over 15 plus x. Now we've actually got to write this down as our equation. They say they do it in equal time. In equal time, that means upstream equals downstream. So now we're going to create the equation where we say up equals down. Okay, upstream equals downstream. And now we're going to use our equation. 8 over 15 minus x equals 12 over 15 plus x. Here's my line there. Okay, I'll make fraction lines. Okay, so now we've got our equation. Upstream equals downstream. And now we need to solve. Solving this equation, we need a common denominator. Both of our denominators are different, so we're going to use them both. So, this guy and this guy we're going to use. So these are the easy kinds because literally all you're doing is cross multiplying. The bottom left multiplies to the top right and vice versa. So, we're going to have 8 times 15 plus x equals 12 times 15 minus x. All on top of our common denominator, which is 15 plus x, 15 minus x. 15 plus x, 15 minus x. Okay? So now we need to do our common denominator, our non-permissible value. What is x not able to be? Right, plus and minus 15. Okay, so x doesn't equal plus and minus 15. Okay, now our bottoms are gone. All we need to do now is multiply in our numerators. So we're going to multiply in our brackets. Please follow along in your notes. Copy this down. Ready with me? Okay, multiplying into the brackets, we are going to end up with 120 plus 8x and 120 minus 8x. Well, one of them, sorry, is wrong. One of them's 80. Which one? This one? Okay, let's look at the right-hand side again. This is going to be 180. And it's going to minus 12x. All right, now we've got our situation clear. At this point, we are just switching sides of our equal sign. So we're going to take x to the left. So I'm going to plus 12x's to both sides. And then I'm going to remove the 120 and take it to the right. So I'm going to subtract 120 from both sides. Okay? We're going to add like terms on both sides now. This is going to give us 20x. What is it doing?
Ryder, call it critical means science account.
I do, yeah.
That's critical means.
Wait, say it one more time.
Critical means.
Dirty boy me?
Oh! After our little interlude, we are now going to finish our question. Divide by 20. Whoa. Dividing by 20 to both sides, we're going to get x equals 3. So that means the current in still water is 3 kilometers an hour. So upstream is 18 kilometers an hour, and downstream is 15 minus 3, 12 kilometers an hour. Okay? Okay, this concludes our first two types of solving equations.